Welcome to physics and mathematics lovers. In today's lesson, we are going to learn this topic on the board, which is motion under gravity. So I did a paperwork on this topic, even solved some examples up to about 5, but not everyone understands paperwork. So some people need a video explanation. So which is why I am here to explain everything you need to know about motion under gravity. As we all know, motion under gravity is taught in grade 10, which is the SS1. But here in SS2, we need to repeat it again because of projectile. Because with the knowledge of motion under gravity, we will be able to understand fully the projectile motion we are going to learn in our subsequent lectures. Now, let us look at motion under gravity. So from the word motion, we already know what motion is. Motion simply means movement, okay? Movement or change in position of an object with respect to time. But now let us consider the one under gravity. So we know that gravity is that pulling force of the earth. That is gravity. Now, when we say motion under gravity, it simply refers to the motion of objects when the only force acting on them is gravity. So that's what it means. Now, when an object is taken to a height from the surface of the earth and released, it will move towards the earth. This phenomenon was first observed by a great scientist called Galileo Galilei, and later Isaac Newton also did job on this. So motion under gravity means when an object is launched into the air and is allowed to move freely, it will fall under the influence of gravity. That is what it means. Now, when dealing with motion under gravity, let us consider this one in one dimension. So this particular topic is motion under gravity in one dimension. So let us look at when this object is taken to a height and the object is released, it will fall towards the surface of the earth with an acceleration which is known as acceleration due to gravity. And this acceleration is denoted by g, small letter g, and it is approximated toward 9.8 meter per second square, or sometimes you see 10 meter per second square. This particular acceleration due to gravity varies from the surface of the earth. It's very greater at the point near the pole. That is where this acceleration is greatest. But at the equator, it becomes so small. So that is how this acceleration varies from places to places on the earth's surface. Now let us look at, in dealing with this motion, let's consider two scenarios. One, the first case is when we launch an object vertically upward. Look at it here. When an object is projected vertically upward, we are going to this point. It means at this point, the final velocity v equal to 0. Because here we are moving upward. So at this point, the final velocity becomes what? 0. That is, here we have the initial velocity. Initial velocity is what we use in projecting this object. Then getting to this point here, the final velocity decreases. And at that point, the object starts coming down. That is where it will come back to original point of projection. Now, second scenario, if an object is dropped from the height, if an object, this is ground level, this is your ground, an object is dropped. Now, object is projected from here, going this way, get to this point, the final velocity becomes 0. Now, at this point, object is on the height here, resting, and the object is dropped. So the initial velocity here is 0. And as it's coming down, it comes down. It comes down. And at this point of dropping on this ground, so the height, that is s equal to height equal to what? 0. So these are the things you need to know about motion under gravity. So this will help us to carry out calculations on this topic. Now, if this place is h and it is 0, the horizontal distance now. Now, what if as we are moving upward, the acceleration which we need will become, as you are moving upward, the acceleration gives us what negative g. Why? Because we are projecting against what? Gravity. So every object is allowed to fall towards the earth. So this is what the law is actually saying. So when an object is released up, as it's released up like this, comes down. As it releases up, it comes down. Now, if the object is already resting like this, it means the initial velocity of this object is what? 0. Are you getting that now? Now, as it is dropped, coming down, so the rebound velocity is where we use this v square equal to what? U square plus or minus what? G, okay, plus or minus 2gs. And now, at this point, when the object is dropped, because the object is at rest here, is dropped down. So it means acceleration is equal to positive g. Why? Because the object is allowed to fall freely under the influence of gravity. So in our kinematic equations, which we studied earlier, so we are going to change it to become this motion under gravity. So now, you remember that your kinematics, we have v equal to u plus at. This is for the kinematic, the motion of a uniformly accelerated motion in a linear, that is a linear motion. Now, when we are now working with this on motion under gravity, so this becomes v equal to u plus or minus what? Gt. Depends on the direction, whether you are projecting upward or you are dropping an object. So if you are dropping an object, so it becomes positive gt. That is u plus what? Gt. Then when you are projecting vertically upward, so it will take the minus sign. Now we also know that in our kinematics, we have s, the total distance, which is for ut plus half at squared. Now, in this motion under gravity, because we take s as the maximum height attained, it becomes h equal to ut plus or minus gt squared. So we also have this formula that says v squared equal to u squared plus 2as. So we replace this one, become v squared equal to u squared plus or minus 2gh. So don't be confused. This h and this distance, they are the same. So we're talking about distance between 2 points. So this motion under gravity, it is now the maximum height attained. Look at the point here. Now the object is dropped. So the greatest height obtained is this. This is the greatest height obtained. That is where we normally use h. So sometimes in calculations, we can still use s, okay, equal to h. Nothing what is different. Nothing is different, okay? So this one can be used to get this maximum height attained. We can use here to get the maximum height. How do you calculate that? Since the final velocity is equal to 0 at this point here, at our greatest height, the final velocity becomes 0. We can put 0 equal to u squared minus, because we are projecting upward now, it becomes for negative. That is 2gh. So we can take this one to this side, become u squared equal to 2gh. So we can get this height attained, which h equal to what? U squared all over what? 2g. So this one is for vertical projection. When you release, when you project an object vertically upward, so to get the maximum height attained by that object, so we make use of this word formula. So we make use of this. That is the greatest height equal to what? U squared all over what? 2g. Now, what about the time with which the object will get to the up and then return to the down? So we have the time to reach the maximum height and also the time to return. So the time to return is the same time to get to the maximum height. So the time it takes to get to the maximum height and return down is known as time of flight. So the object will go like this, as assuming the object is projected from the ground like this. As it gets to this point where the final velocity becomes 0, the object returns back. So the time it takes to get to this point and also comes to the ground is what we call time of flight. And that time is capital letter T. So it's usually 2 of this small letter t. So which means from here, how do we get our t, the time to get to the maximum height? So let's go. Now, the time to get to this maximum height here, we can get it from this point. We have v, because as we are going up, because v equal to, we have a u minus gt. So that is the time. And we know that our v is 0 at the maximum height. So we become equal to u minus what? Gt. So take this u to this side, take this gt, we have gt equal to what? U. So which means t equal to what? U over what? G. So this is the time it takes to get to this maximum height. Now, what is the time of flight now? Time of flight is equal to 2 times the time to reach the maximum height. So we just multiply this one by 2. So t is equal to 2t, which is equal to 2 times u over what? G. So this time is now what? 2u over what? G. So this is the time of flight for an object projected vertically upward. Okay. So why do I have to explain this? So in our projectile, we are going to be making use of this knowledge. So this one is just the motion under gravity in one dimension. But in projectile, we'll be considering the 2 dimensions where we have the x and y components of that word velocity, which is used to project the object. So in this class, this is where we are going to stop now. Now, our next class, we are going to solve examples on this topic, so that we can be able to familiarize ourselves with questions under this particular topic. So nothing differs from here. So with the motion of the equations of linear motion, the only difference is just the replacement of acceleration with this either plus or minus g. That's all. So if you find this class very interesting, please help us to like, comment, share this post. Do well to subscribe to my YouTube channel, Physics and Mathematics Lovers. Bye.